Okay.
All right, so for the benefit of the class, how we do summer school is we work in 6-day rotations. The first 3 days we rush or new material. The 4th and 5th day we review, and on the 6th day we test. So today and Monday will be review days, and then Tuesday is the first test. What I've done is on Blackboard, I've posted 2 sets of tests. There is the spring 213 test from this year, and then there is the, where are you? Summer test. Come on. You can do it. All right, and then the summer test from last summer. So you can get an idea of what these tests look like. The test is half multiple choice. So you need to bring a Scantron, and I want the green Scantron. It's the green. It's the narrow, long, 50 answers to a side. Bring that. You can bring pens, pencils, erasers, all that stuff. I even allow highlighters. You can bring a ruler if you want. You can bring colored pens, pencils, all sorts of stuff. You're allowed to bring in crayons, but I don't encourage it. So I give everybody a lot of freedom to do what they need to do. Initially, the tests were just a blank front page and then problems, but now I've gone over and put in a lot, not rules, but just reminders. You need to read everything. I mean, that just goes with the territory. Test will end at the time stated. Because this is a 2-hour class, I write the test for 1 hour 15, and then I give you the full 2 hours. It's mostly because we're in such a rush to learn all this material. This is like the 20th, 21st semester I've taught this course. One of the things that I do appreciate, I think it's obvious, a happy grader is a generous grader. So don't do things to upset them. What makes me happy? Great penmanship. Don't scrawl all over the page. Be coherent, write line after line after line, label everything. You may want to highlight your answers. Anything to help us makes us happy. Anything that we rule as unreadable or confusing, we won't grade. So if it's just horrible, we won't do anything. No notes or books. When you come in on Tuesday, you're going to take your book bags and leave them up at the front. We won't start unless all the book bags are not in that area. And this is one of the most important things. On these pages, you see work and answers on this page will not be graded. You also see that it is on the multiple choice section. Question, on the MCAT, on the SAT, on the ACT, if you circle the right answer in the test booklet, but the wrong answer on your bubble sheet or Scantron, do you get the points? No. So we're doing that same rule here. If you have the answer on the test but not on the Scantron, you don't get the points. I'm just fair warning. Also, and there's a reason for this. Having to flip through 6 pages of multiple choice takes a lot of time. Putting it on a Scantron takes roughly 5 seconds. Also on the test, well, let me show this. There would be like equations. So I'm going to give you some generic equations. What you do with it is your own business. The one thing that I won't put on this page, common volumes, such as volume of a cylinder, a cube, a rectangular object, stuff that you should know because you're a human and you're in college. Also here, this is a sample test that we're going to go over today. These are the typical problems that you'll face. Shocking, it's very similar to what I've shown you or told you about before. It's a conversion, vector addition, 2D motion, Atwood's machine, done. That's it. For a test like this, typically, I expect the test to pretty much be over by an hour 15, hour 20. If you need all 2 hours, you can have it. And I know that if I gave you guys 8 hours, there would still be someone who would just sit there and all 8 hours and have to pry it out of their hands. So, it will end at noon. There won't be any extra time after that because the test is really geared for an hour and change, not the full 2 hours. One of the reasons why I put this working answers on this page will not be graded is that there are people who attempt to put the answers in these little spaces in 5-point font and we can't read it. Like they will try to cram the whole thing in. I will give you there will be a ream of paper in this room. Take the time, write it out legibly, probably 1 problem per page, rather than cramming it all in here because it makes it difficult for the graders to read. Now what we're going to do is we're going to go over this version of the spring 213. On Monday we'll do the summer 213. After I get done with this, there are multiple versions of this test. So what you'll notice is for the multiple choice for one version will not be the multiple choice for the next version. This is mostly because in a room of 180 people, you can't physically separate the students. You guys will only have one version, but one thing that I'm going to do with you is we'll alternate rows so we don't have people looking over. Probably after we fill up all the alternating rows, then we will just fill up the first row and then the second row just because then it's more easily controlled. Or I've got desks, we can put more desks in here. So there will only be one version of the test. It makes it easier for everybody. What I'm going to do now is we're going to play our game. Oh, and after this test, or after this mock test, what we're going to do is if you have any questions about homework, any questions about the test, I'm going to open the floor up and we'll talk about whatever we need to talk about. So let's take a look. So displacement over time is what?
Average velocity.
Average velocity, yes. Chad Kelly throws the ball to Coach Freeze. There is no wind resistance. The ball experiences acceleration that is only vertical. Gravity only acts in the vertical. The normal force is always blank to the surface. What is blank? Perpendicular. Good. Now, this sounds a lot like when I'm asking you those rapid fire questions in lecture. Those are all multiple choice, potential multiple choice. An object slides across the floor. Which value is not used? Static friction. Negative 3x hat minus 3y hat is a third quadrant vector. Real quick, and this is also what I do. I ask other questions while I'm answering these. What are the signs for a fourth quadrant vector? Positive, negative. Is 2x hat plus 3y hat a third quadrant vector? No, false. Okay. To convert cubic feet to cubic yards, you must divide by 27. 3 squared, 9, 3 cubed, 27. Up is to down, as resultant is to equilibrium. Why did you think velocity?
It was mass and then acceleration.
Okay. The absolute value of velocity is called what? Speed. Velocity is, now this is another question that I'm just coming up with. Velocity is to speed. Velocity is to speed as displacement is to what? Distance. Excellent. Which of the following is the smallest? Nanometer. Okay, so now some more rapid fire questions. Nanometer is 10 to the what? Negative 9. 10 to the negative 6 is what? Micrometer. What is the Greek letter for micro? Mu. Okay. Kilometer is how many meters? 1,000. Not on the list. 1 million meters is a megameter. All right. This is a good question. You push a 2 kilogram blocks across the floor with a force of 200 newtons. Its dV dt is 0. What is the sum of the forces in the x direction? What is the sum of the forces in the x direction if its dV dt is 0? Incorrect, but you said it with confidence. It's what is the sum of the forces generically? M times A. Well, what's A in this case? 0. So M times 0 is equal to the sum of the forces. So the answer is 0. Oh, we did this. Distance is the absolute value of displacement. Now, 12, actually, I'll make sure these don't scroll off the page. You are walking forwards and speeding up. Which is true? And actually, the answer is on the page. It points forward as well. So if you're speeding up, your velocity vector and your acceleration vector are in the same direction. If they are slowing down, the velocity vector is one way and the acceleration vector is in the other. So if they are in opposite directions, if they are anti-parallel, you slow down. If they are parallel, same direction, you speed up. Now we need to have our figures. Using figure 2, which is here, mg is what? So it's 1, 2, 3, 4, and 5. Which one of those is mg? 4. That is mg. And actually, what I also do over the weekend, I'll make sure that the double answers are gone. Negative 2x hat is what in polar notation? Or I'm sorry, they all are in polar notation. Oh, hold on. Negative 2x hat is what in polar?
2 meters and 1 acre.
Mm-hmm. Chad Kelly throws the ball to Coach Freeze. Which of the following is a valid velocity vector when the ball is at its highest point?
Meters per second.
2x hat. Now what we need to do is we'll go over two-dimensional motion more for today and on Monday. But one of the things that you need to think about is, say I hit a ball and it comes up and it goes down. At this particular point, the velocity vector is heading in that direction. At the top of the curve, the velocity vector looks like that. It is pure horizontal. As it comes down, the velocity vector points typically in that direction. So the velocity vector changes, but the one thing that you know at the top of the curve, there is no vertical velocity at the top. As it's coming down, the velocity vector and the vertical returns. Oh, excuse me? You just want to see that. Okay. So the answer is 2x hat. Now using figure 2 again, which of these is the normal force? 2. Kilogram is a unit for mass. All right, now let's continue, and I got to remember to do. Okay, before we continue, what are the units for displacement? Meters. Meters, and say it with confidence. Don't go meters. Velocity is what?
Meters per second.
Acceleration is what?
Meters per second squared.
Force is what?
Newtons.
Newtons or
Kilograms, meters per second.
squared.
Yeah.
How do you get that? You know that force is equal to mass times acceleration. What are the units of mass? Kilograms. What are the units of acceleration? Meters per second per second. And so that's how you could get it. I never remember kilograms meters per second squared, but I know that F is equal to ma. And so that's how I get it. Those are all the units. Which of the following is the largest? 2 times 10 to the 4th, because 12 times 10 to the 3rd is 1.2 times 10 to the 4th. Oh, we didn't do 18. Chad Kelly throws the ball to Coach Freeze. There is no wind resistance. Which quantity changes? Vertical velocity. There is no acceleration in the horizontal, so the horizontal velocity will never change. Vertical acceleration is because of gravity, so that will never change. Gravity doesn't change. Mass doesn't change. Convert 2 meters into centimeters.
2 times 10 squared. Centimeters.
Yeah, 2 times 10 to the 2, because 100 centimeters is a meter. Now, 21, I'm going to warn you about the snark rule. When I say you drop an object, what is its initial acceleration? I am speaking about the moment immediately after I let go. So it is now a free object. What is its acceleration?
Negative 10 meters per second squared.
Negative 10 meters per second squared, which is that guy. Speedometer in the car measures what?
Instantaneous.
Instantaneous speed. Now, we do get occasionally people, there's one person who is like, I don't drive a car. And I'm like, you're in college. You should know what a speedometer and odometer. Odometer measures what? Distance. Now, does it measure displacement? No. How do we know this? If you've seen Ferris Bueller's Day Off, they tried to roll the odometer down by putting it in reverse and just letting it run. It didn't work. So odometers measure distance. We'll get to 23 in just a moment. Chad Kelly slides into the end zone. He is slowing down during the motion. What can we say about the forces acting on Chad? Now, E is scrolled off. Let me take a look. Are there no forces acting on Chad? No. Well, technically you got gravity, but since he's slowing down, what other force is involved? Friction force. And there's also normal force. The net force on Chad in the vertical is non-zero. Is that true or false? The net forces on Chad in the vertical are non-zero. Which it's false. Also, I really like it when students argue amongst themselves. Why is it false? Gravity and normal force. Also, what do you observe about Chad? He's not entering the earth and he's not flying off the earth. He's sliding. So the net force is zero. Friction isn't involved in this action. Well, that's false. You got friction for sure. The net force on Chad in the horizontal is zero. Is that true or false? That's false, because he is slowing down, so there is an acceleration, which means that the sum of the forces, which is equal to ma, is non-zero. E is the answer. What should be written is the net force on Chad in the horizontal is non-zero. So two meters at 180 is what in component notation? Negative 2x hat. Now, the reason why those problems exist is that I'm trying to remind you when you go to do the vector addition problem, one of the vectors will be an instantaneous conversion vector. One of the vectors you should just look at and go, done. 2 meters at 180, therefore that is negative 2x hat. Move on to the other one. The last one, number 23. Using figure 1, if G is position, so G is my position plot, what is my velocity plot? So G starts initially steep, and then it gradually, the slope becomes zero. It's plot D, yes. So all of that dancing that I did in front of you and drawing all those plots, the pre-lab for the one-dimensional motion lab, or the questions, the ones where it's got a grid of 9 and it gives you 3 different objects and how they move. Know how to do that. Be able to identify the graphs. I'll try to put a few more of those problems into the 25 multiple choice. If D is the velocity, which one is acceleration? E. What's the slope of D?
Negative.
It's a negative and constant. So a negative constant value for acceleration can only be meant by E. If if B is acceleration, which one is position? H. Because if B is acceleration, which one is velocity? A. So A shows that the initial slope of position is 0 and then increases with time, which is what that plot is. So being able to just quickly go through, if I said there are two answers, or actually there are three. You standing still, the position plot could look like blank, blank, or blank.
C, E, or B.
C, E, or B. For a constant position, that's constant, that's constant, that's constant. So either of those three would be correct. So I would just look at different things like, if A is my position, which one is velocity? B. If A is the position, it is moving at a constant rate and an increasing value. That means it has to be B. And if B is the velocity for A's position plot, which one is acceleration? C, correct. Very good. So being able to transfer back and forth between velocity, acceleration, and position for accelerating objects, slowing down objects, all sorts of stuff. And that's where this plot comes in. So the last thing before we open the floor is we're gonna do a test. What I'll do is I'll write this down so that we don't have to have this test up all the time. So the first, now how I did the versions, I believe in this particular case it was the value of the conversion. Like one had 31, the other one had 33, and the other one had 35. But since we all have the same version, it doesn't matter. 31 cubic meters per hour, and I want to change it to cubic inches per second. So you're going to get something where it's an area or a volume over time, and you're going to have to do a double conversion. There are, in 1 hour, 60 minutes. There is in 1 minute, 60 seconds. I don't square those because I'm dealing with linear time. So you're not dealing with seconds squared or meters squared or hours squared, anything like that. But the meters are squared. So meters, 100 centimeters per meter. Well, not only, they're not squared, they're cubed. Centimeters goes to inches. 1 inch, 2.54 centimeters. Quantity cubed. And that's the conversion. So I wouldn't normally do this, but here's the numbers. 31 times 100 cubed divided by 60, 2.54 cubed. And then I have it. And I get 525.5 cubic inches per second. You could probably write 526, either way would be fine. In terms of, accuracy. We know you guys are plug and chug fiends, and so we write problems that try to avoid it, but we still know that you guys still do it. If the answer is within 2%, we're fine with that. We're not going to get picky about sig figs. Scientists do place great value in sig figs, but what I've found, in my opinion, you guys focus on sig figs so much that you ignore the little things like physics. So what we try to do is just avoid it pretty much altogether. Eventually, when you get into upper division labs, you're gonna learn about sig figs and you're gonna learn how to be picky about them, but not today. So that's the appetizer. You're gonna do a unit conversion. Next, a vector addition. I don't even write B before I look at A and go, that's an instant conversion vector. It's a multiple of 90. What does that turn into? Negative 3y hat. The other thing that I say about tests are, I don't care about units in the middle of a test, within the problem itself. If you don't write out your units within the problem, that's fine. If you don't write your units at the end, that's a big sin. So remember to have your units in the answer, but in the middle, it doesn't matter. The B vector. Four meters at 135 degrees. 135 degrees is a what quadrant vector? Second. So what I do is I first so the vector kind of looks like this for B. And that is 135 degrees. That is my reference angle. My reference angle for a second quadrant vector is 180 minus the absolute. So it's 180 minus 135, or 45 degrees. Now, drawing this out, B magnitude, which I will say is little b, x, is that, and little b, y, the magnitude of b in the y direction is this. Sine of theta, r, is opposite divided by the magnitude of the b vector, or hypotenuse, big B. So big B sine theta is by. So 4 sine 45 degrees is 2.83. And notice that everything is positive. When you're breaking the vector down, when you're using the reference angle system, all calculations that you enter into the calculator, all calculations that you get out of the calculator are going to be positive. When you get the inverse tangent, you're using all positive numbers. When you're putting in cosine and all that, you're using all positive numbers. We're dealing with magnitude. Yes?
Do we have to use the reference angle method?
Okay, so it is a free country. You are free to do as you see fit. The problem that I face from my end, there are dozens of ways to add vectors. So if I spent all the time going over what vectors, procedures, we'd spend the whole month. So I gotta pick one method that I really like that is as lean and mean as possible. If you do it your way and get it right, more power to you. If you get it wrong, the graders are gonna punish you for it. So it's because they're trained to grade it in the way that I teach it. Since I see the scanner, we don't scan. Have you guys gotten nasty emails about not scanning? All right, I need to turn that off because occasionally I'll get this slew of messages going. The university is going to kick me out because I have 5 absences. Don't worry about that stuff. Let me handle it. So bottom line, I prefer you to use the reference system. I think it's the simplest way, but if you've got a way and it works for you, good for you. Cosine theta is bx over b. So bx is b cosine theta, which is 4 cosine of 45, which is again 2.83. One of the things that I love about 45 degrees is cosine of 45 is the sine of 45. Just as I like sine of 30 is 1/2, cosine 60 is 1/2. So there are some trig things that I like to deal with. So let's write out these vectors. The a vector is -3 hat. We've done step 1. We've broken the vectors down. Step 2, add your x's to x's, y's to y's. 2.83 x hat, 2.83 y hat. I haven't put the signs yet. In the reference angle system, you're dealing only with magnitudes. Love magnitudes because I have self-will and I'm the one in charge of making decisions about signs, not the calculator. I know for a fact that the b vector is second quadrant, with the magnitudes of its components being that. But if I'm going to write the b vector in full component notation, which of these values are negative? The x. So I put a minus sign there and a plus sign there. I'm the one, you're the one making the decisions, not the calculator. Now we add them together. And we get this. That is the resultant in component notation. Now in the test, I don't know if I'll do this. Maybe not. I haven't decided. But you guys know how to get the equilibrium from the resultant. For a component vector, you just flip signs. So the equilibrium is 2.83 x hat plus 0.17 y hat meters. The equilibrium, when added to the resultant, would give you 0. So that's why you can just flip signs. The last step, finding polar. Once again, you draw out your third quadrant vector. Because it is third quadrant, I got a negative as my resultant. Because C is a third quadrant vector, I know that my reference angle will still be between 0 and 90 degrees, but my absolute angle must be between what? 180 and 270, correct. So we draw just a generic third quadrant vector. So it looks like that. In the event, oh, well, blah, blah. So big C, the magnitude, is cx squared plus cy squared. This gives you 2.83 squared plus 0.17 squared square root. Should be close to 2 point. So again, 2.84 meters. So that's the magnitude. So the magnitude of C is 2.84. Magnitude of D is 2.84. Our last part is determining directions. Theta R is always the inverse tan of the opposite side. The way that the reference angle system is set up, it's always the y side. So cy divided by cx. You do not put negative signs in this equation. You never put negative signs into your calculator when adding a vector, unless you're just physically adding them up. So this becomes inverse tan of, hold on, I'm brain freezing, right? cy, which is 0.17, cx, which is 2.83. So I get 3.4 degrees. That is my reference angle. A reference angle, when converting to an absolute angle in the third quadrant, theta A is 3.4 plus 180. So C is 2.84 at 183.4 degrees. Now, to get the resultant vector, if your absolute angle is above 180, you simply deduct 180, and that's the case for this. So the D vector is 2.84 meters at 3.4 degrees. And so that is the vector addition problem. Yes?
You want us to always round to the 100 in the component?
I would say for the typical magnitudes, an answer like 2.81 or 2.8 I would see is fine. The other thing is that the angle, if it's within, because typically when we grade, if the official answer is 2.83 at 180 degrees and you have 2.8 at 179, close enough. If you had 4 at 35 degrees, now we got problems. So we're really looking for gross error. Small error or small rounding stuff, not a problem. I would use extra sig figs during the calculations if you want to go to 4 or 5, just to reduce the, I call it bit rot, how the numbers will diverge with enough time and enough calculations. But if you extend out the sig figs during the calculation, then you get a more accurate answer. Question in the back.
What happens if it's not above 180?
Then you add 180.
Okay.
So in both of these cases, if that is the resultant, you just subtract 180 degrees to get the equilibrium. If you have a first quadrant or a second quadrant where the theta is less than 180, you add 180 to get it. And so those are the two different ways. All right, next. All right, problem 2, the 2D motion. First thing as a reminder, knowledge of the quadratic equation and how to solve for it, the negative b plus or minus square root blah blah blah. It's not going to be done on the test. You could do it in some circumstances, but it's not going to be required. The big thing that shows this is the fact that I gave you time. There's another instance that we'll get to eventually, but in this particular case, I have an angle of elevation of 30 degrees, a hill of 50 meters high. The time of flight is 8 seconds. How far away from the base does it land? And what was its initial velocity anyway? This is a 2-equation, 2 unknown problem. You've got a 2D motion problem. So what's the first thing that you do when you have a 2D motion problem? The first thing I say is, my origin is there at the base of the hill. It's the furthest most to the left and down. The next thing that I do is I write my equations that I'm going to need. For something like this, you write x equals x naught plus v naught x t and y equals y naught plus v naught y t plus 1/2 at squared. It's a 2D motion problem. Those are the equations that you always use. The next step, use my favorite number, 0. There are several instances of 0. X naught is 0. The point is directly above the origin. Y final is 0. It lands on the surface parallel to the, or just to the right of the origin. So Y is 0 in that case. The other thing that I know is it's going up and to the right. And I have this. That's my angle. Sine is opposite over hypotenuse, or V naught y is equal to V naught sine theta. Cosine theta is adjacent over hypotenuse, so V naught x is V naught cosine theta. So this becomes x equals V naught cosine theta t. 0 equals y naught plus V naught sine theta t plus 1/2 at squared. Now that we've plugged in all our values and zeros, values being or substituting for V naught y and V naught x, we identify what we know and don't know. I know y naught, I know theta, and I know time. And I know gravity because I'm on the planet Earth. A in this case, because it's ballistics, will be -10. I don't know V naught and x. The equation on the, well actually this, well technically it's a 2, no it's not a 2 equation, 2 unknown. The equation over here on the left has 2 unknowns. The equation on the right has 1 unknown. That equation is solvable. solve for V naught. Before you plug and chug, solve for the variable. One of the other things, since you mentioned sig figs, you get a more accurate answer if you only do one calculation. So this is one of the benefits of using the alphabet soup method. So solving for V naught, minus V naught sine theta t is equal to 1/2 AT squared plus Y naught. Divide both sides by negative sine theta t. V naught equals 1/2 AT squared plus Y naught over negative t sine theta. Now all the variables on this particular case are known on the right hand side. So this becomes 1/2 negative 10 8 squared plus 50 divided by minus 8 sine of 30. I said 8 times sine of 30. Also, it's just as thank you for the reminder. No phones. Put your phones in the bag. Put it up front. There's a penalty of my choice if you're found with your phone on you. The safest place, put it in your bag or put it up on the front table. Also, just as a benefit to the rest of us, be sure, just turn it off. I got my cell phone in case of a tornado attack. We'll know, so don't worry about it. Focus on your test. Let me worry about horrible weather. So this gives me divided by negative. I get 67.5 meters. One of the things that I try to do a lot more now, is in the problems, I will have this equation in a spreadsheet and I will sit there with the numbers until I get a number that I like. As in a number that's like a whole number, or if it's a fraction, like 1/2, 1/3, 1/4, something like that. Something very easy. One of the phrases that could be asked during a test is, are the numbers nice? Which is slang for, are we expecting whole numbers out of this? For the most case, for this, I will try to make the numbers nice. For vector addition, that's just a nightmare. The numbers will never be nice in there. I try and it just doesn't work. Now that I have initial velocity of 67.5 exact, I can get this. This number will probably not be as nice as the other because cosine of 30 is just a nuisance. So I would accept 468 meters. It's actually 467.65, but that's close enough. If you got that and that, they're fine. So that is the initial velocity and the horizontal distance. Notice this. The problems in the homework are nightmares because I'm asking like 10 different values all within the same problem. Remember what I said at the beginning, it is better to sweat in practice than bleed in combat. I'm intentionally doing that so that once you get to the test, you're better able to handle any of the contingencies that may be given to you. It is pretty much a guarantee that I won't ask for V0 and X on the test. I may ask for other variables, which is why the alphabet soup method is so nice. You should be able to solve for any of these variables and solve for that, except for t, because that ends up being quadratic a lot of the time, so it's unnecessary. Atwood's machine. that problem. It is a metaphysical certainty that you will get an Atwood's machine problem. Most likely not like this. But let's just walk through the steps and show you how to do it. The Atwood's machine does have friction. Boo, friction. I'm a big fan of no friction. However, for a summer test, we will have friction in it. So there are two objects I'm really considering. One is on the table. This is M1. It's definitely gonna go to the right and down. I've never given an Atwood's machine problem on a test where it goes up and to the left. It is the 213 test 1 is the most predictable of all tests. I talked to somebody yesterday about it. The first test is only worth 15%. Why? Because you've only been doing physics for 4 days now. Many of you have never had a physics test before. So the test on Tuesday does two things. Helps you, it diagnoses if you have enough knowledge for just really basic physics. And two is to give you experience on taking a physics test. So it's not that big of a deal. If you get a 50 on test 1 and your desire is to get an A, it's still possible. It's going to be really hard, but you can still get an A. If you just want to go, oh, please let me pass, a 50 on the first test, that's nothing. You could easily get that. If you get a 20 on the test, we're going to have to talk. If your desire is, I got a 20 on the first test and all I want is to pass. All I want is a C and the degree and go. With the 20, you can still pull it out. You're going to have to work at it, and it does. The results are kind of indicative of your future returns. A 20 on the first test does not give me confidence that you'll improve on the second test, but it is manageable. We will try to get that first test graded by the end of the day, and definitely by class time the next day. If not, it would be imminent, like basically by 1 o'clock in the afternoon. For this, we have friction force, gravity force, tension, normal force, all sorts of things. And we go through the mantra, how to get acceleration out of this. Well, first thing, find normal force. Sum of the forces vertically is equal to 0. The object is not penetrating the surface. Next, normal force minus force of gravity. Force of gravity is equal to normal force. So that means normal force is equal to M, what did I label it as? 1G. That's the normal force. Step 2, find friction force. Now, a lot of these are fairly trivial because we're dealing with a flat surface. This may not be the case on the final. Friction force is mu sub k times normal force. So this is mu sub k m1g. Now we find acceleration. The sum of the forces in the axis of motion is ma. The forces acting, or m1a to be more particular, the forces that we're dealing with is tension to the right, which is a positive direction for the object on the surface, minus friction force, which is to the left. So m1a plus friction force is equal to the tension on the string. Therefore, the tension on the string is m1a plus mu sub k m1g. And yes, we are looking for derivations for the problem. You pretty much know what you're going to get, so learn the technique. The graders will be looking for derivations in the Atwood's case. You will not get points for writing the thing down and going poof, and then a miracle occurs, and then writing the answer. We're going to have to see your work. The other object, the hanging object, has tension up, M2G down. In this particular case, down is positive and up is negative. Remember the loopy-droopy number line. What starts as left is positive and right is negative, or I'm sorry, right is positive and left is negative. When you bend it, left is negative and down is positive. So that's why. The forces in the vertical acting on M2, which is M2A, is equal to minus tension plus M2G. The forces down are positive, the forces up are negative. G in this case, we're not using A, we're using G. G is the magnitude of gravity, which is 10. Or T is equal to M2G minus M2A. Those tensions are the same. There are multiple choice questions that say the tension on mass 1 is blank to the tension on mass 2. Is it greater than, less than, or equal to? I'll repeat the question. The tension of the string on mass 1, is it greater than, less than, or equal to the tension on the string on mass 2? They're equal. If it was unequal, the string would snap or bunch up. One of the two, but it remains taut, so it moves as one. Another question, the acceleration of mass 1, is it equal to, greater than, or less than the acceleration of mass 2? Or repeat it. The acceleration of mass 1 compared to the acceleration of mass 2, is it greater than, less than, or equal to?
Equal to.
Equal to. They move as one. Not only are the tensions equal to each other, the accelerations are equal to each other, and the velocities are equal to each other. Technically, the tensions are not always equal to each other. Only if the pulley has mass. In our pulleys, they are massless. If they had mass in the pulley, we'd have a whole evil problem to deal with. So let's just be thankful. In 213 physics, the accelerations, tensions, and velocities are all equal. Not to each other, but velocity of 1, velocity of 2. So you set those equal. And we get this. We now solve for A. Now, if I got an answer of -5 meters per second, is that possible? In the way that this problem is arranged? No, because That's so much heavier than this. I typically make the mass differentials enough so you just look at it, and without knowing physics, you go, well, that's going to fall. If that one was 2,000 kilograms and that one was 20, we'd have to think about it because of friction. But the number line system is plus and minus. If that had a negative acceleration, it would go up and to the left, which is, in this particular case, is physically impossible. So if the number that kicks out of this is negative, then we got a problem. What is the maximum value of A possible in this problem? 10. Because if, let's say M2 was infinitely bigger than M1. If M2 was really, really big compared to M1, we could simplify this problem as A equals G. M, really big number minus really small number, is that big number. Really small number added to the big number is the big number. And you're left with G. With no external forces other than gravity acting on this system, the maximum acceleration that it could have is 10. So if you get a number that's negative, go back and figure stuff out. If you get an answer that's greater than 10, go back and figure stuff out. The answer is guaranteed to be between 0 and 10. Plugging in our values, excuse me. After giving so many tests, I have become eternally paranoid that I will give problems that are numerically impossible. So what I tend to do is the day before a test, I will do the test and make sure the numbers all work out. I understand I have a PhD in physics and you don't, which means I should be able to do this test faster. Typically, an hour, 15-minute test for you should take me about, including the multiple choice, about 20 minutes, 15, 20 minutes. Just raging through it. Now, granted, it's taken me 67 minutes to get to this part, but I'm explaining all the steps to you and we're going slowly and thoroughly. You should be able to do a test like this in about the same time. So this is 17.5 times 10, 175 divided by 25. Also, I love numbers that work out well. Because you ask about sig figs, and the answer to this number, if you do the one calculation, the answer is 7. Not 7.01, 7. If you do these calculations and a pure, clean integer pops out of it, you go, I did it right. That reassures you that you're on the right path. Now, granted, you're beginning to learn my test style and my problem style. We're going to get to the last part of this. I disagree with those who do mastering physics and then write their own tests, because I think that what happens is a disconnect arises between the problems that you do on mastering physics and the problems that you do on the test. A lot of people get used to doing mastering physics and then they walk into the test and then they just trip all over themselves. So the problem sets are mock tests in a way. I also don't ask for things in a linear fashion. When you had this, the first thing you needed to do was find acceleration. Though the first question is, how long does it take for the mass to reach the bottom? So don't assume that the answers or the questions that I ask are in the order that you need to do these. It's effectively a one-dimensional problem now. You have a 20-meter drop. The beginning of the motion we'll say is our origin. It has an acceleration of 7 meters per second, so x equals x naught plus v naught t plus 1/2 at squared. It's stated explicitly in the problem that v naught is 0 and has just overcome static friction. The object starts at the origin. I have my a, 7. I have my x, 20. Find t. And I don't think this will be a nice... .39. Frequently, I can get the first number to work out really nice, but to get to that number and plug it into another equation, specifically with a square root symbol in it, I'd have to spend a lot more time soothing the numbers to make it work out. And so that's a test. So being able to go through the whole test, slowly, thoroughly answer all the multiple choice questions, took us 1 hour and 11 minutes. I really don't expect this room to be full at the end of 2 hours. We should be down to like the 2 or 3 that I'm gonna have to get the crowbar on and just pry that thing out. Most of you, don't be surprised if you're done in 1 hour. And most of you should be done in 90 minutes. Because I don't want to give a lecture. You don't want to listen to a lecture after a test. So that's just what I do. That's the test. We will do the other one, whatever one we didn't do today, and we will do the other one on Monday. What I'm going to do now is we've covered the basic material. We've covered the multiple choice. If you want to look at other multiple choice, we will not do test reviews, but test reviews are all online. I will even go back, and today is the day. I will send you the link to the Google Drive so that you can look at all that stuff and just look at it to your heart's content. So what we're going to do is answer questions today. It could be about homework, it could be about anything. And then over the weekend, go through problem set 3, figure stuff out, and ask me more questions on Monday. So, who has a question? Or do we all know physics? We could take the test right now if you want. So we all know the homework and we all know the test. Yes?
Can you do number 13 on the homework?
13 on problem set 2. Okay. Now, number 13, a ball is fired with a velocity of 200 meters per second and an angle of 38. Why I picked 38, I don't know. It's on a 200-meter cliff. If the surface beneath the cliff is level, when and where does the ball land, and what was the maximum height of the ball? Which is a very good topic to talk about. This is the value of the ball at its distance above the floor, not the distance above the lip of the cliff. What is the velocity vector the moment before impact? And the reason why I have the anti-snark rule is because of Meg. Meg years ago wrote all her answers on the first test in units of furlongs and fortnights. And I was like, and she said, you didn't tell us what units to use, so I used furlongs and fortnight. Ha ha ha. So I got rid of that. That's also another reason why I say the velocity the moment before impact is to eliminate the people who go, it's 0 because it hit the surface. First, sketch this thing out. Now, the initial tip is that we're going to deal with a quadratic. So I got my quadratic app ready to go. It has an initial velocity that's given 200 meters per second, roughly 3/5 the speed of sound. But that's okay. We're also not dealing with air resistance. We have an angle of 38 degrees. And the question is, what's the time that it takes? And how far away from the base of the cliff does it land? So this is a classic two-dimensional motion problem. What's the first thing that you do? You label your origin. Lower leftmost corner. Technically, you could pick any corner to be the origin. If you picked over here to be the origin, that coordinate would be -x. If you picked that as the origin, that would be -200 for its initial, or for the y value here. But I tend to pick the lower left because then I know everything above and to the right is positive, regardless of x or y. So I write those two motion equations down. Earlier today, someone asked about, there was a mention in, actually it's mentioned in the problem set too. For each exercise, you must derive all equations that will allow you to get your numbers. You're only allowed for the tests and the problem sets and the final to start with those two equations and their associated velocity equations. I do it for you. I do it for your desire to be lazy, or as I say, efficient. Why memorize 8 equations when 2 would just be fine as well? So for these, I gotta go, well, plug in my zeros. X naught is 0. Y final is 0. V naught x is V naught cosine theta. V naught y is V naught sine theta. If you guys were like 211 students, I would require you to derive V naught x and V naught y, but it's all related to you could just look at it and go cosine theta is V naught x over V naught. So V naught x is V naught cosine theta. Okay, next. Rewrite these. And you get this. The next thing that you do is you identify what you know and don't know. Anything that I do know, I'll mark in green above the variable. Anything I don't know, I will mark in red beneath the variable. Don't know X. Definitely don't know T. I do know V naught and theta. This equation has 2 unknowns. I'm not really dealing with this right now. This equation, I do know A, theta, V naught, and Y. The only unknown is T. So this is not a 2 equation 2 unknown. This is a quadratic equation. I need to rewrite this equation in a quadratic form. So 0 equals 1/2 A T squared plus V naught sine theta. Oh, that's a horrible sign. Sine theta T, that's the T term, and then Y naught. So 1/2 negative 10 is negative 5T squared. V naught is 200. Sine of 38. Why did I pick 38? I should have picked 30. That's a much better number. 200 sine 38. 123.1 T. And Y naught is 200. So let's get this in the -5, 123.1, and then 200. So the solutions for this, if you've got the quadratic solver in your calculator, and a lot of people do, A, I'm not going to have you blank out your memory, and B, it's not going to be necessary because we're not going to use these, or we're not going to use quadratics in the test. The times that I get are 26.15 and -1.530. The negative number is nonsensical. Can't have negative times, so the time that we do use is 26.15. So the time, I would rewrite it as 26.1. In my calculations, I'll use 26.15 because it's a little more accurate than the other. To find X, plug that T into here. V naught is 200. Cosine of 38. You're not going to get 38 degrees on the test. T is 26.15. And I get 4121.3, or you could just write 4121 meters. That's good enough. And so that is that's the time and the effective range of the object. We're not done yet. Problem 13 also has us ask, give me the maximum height of the ball and the velocity vector in polar and component notation. I'm going to attack the velocity one next. Whenever you have two-dimensional motion problems, those are the two equations that you attack with it first to figure out locations and time. Now that you've got everything, we can use the velocity equations. Vx is v naught x and Vy is V naught y plus AT. These are the components of the velocity vector. 200 meters per second at 38 degrees is a polar vector. You could break it down and rewrite it as a component. What we're going to do with this is we're going to plug in time to get our components. Our V naught x is V naught cosine theta. Our Vy is V naught sine theta plus AT. So our Vx is 200 cosine of that 38 that I don't like. This is 200 sine 38 minus 10 times the time, 26.1, because we're only considering the values, oh crud, I shouldn't write it that way. (200 sine 38 minus 10 times 26.1). The only thing that I don't like about writing on the Elmo is that I can't easily erase stuff. I just have to scratch it out, unlike the whiteboard where I can erase it and rearrange it. This gives me a final velocity in the x of 157.6 meters per second. The other one, now I've got a question. Putting money, well, you're already calculating it, so you should figure it out. It should be a negative number. Why? Because I know this for a fact, this thing is coming down and to the right. So the Vx will be positive, but the Vy will be negative. And I get minus 137.9. The reason why I do these parts of the problem is that I want you to practice on A, calculating the final velocity, and B, being able to recombine your vectors. This becomes positive 157.6 x hat minus 137.9 y hat, close your brackets, meters per second. And so that is the final velocity vector in component notation. It's a fourth quadrant vector. It's going down and to the right. It means that it's between, its absolute angle is between 270 and 360. Draw it out. The magnitudes, Vx and Vy, are 157.6 and positive 137.9. The velocity magnitude is Pythagorean theorem, 157.6 squared plus 137.9 squared. And there we go. (209.4). And already we're getting a little bit of bit rot. Our reference angle is inverse tan of opposite Vy over adjacent Vx. And these are the, once again, these are the magnitudes. Do not put in negative numbers into this calculator because I'm getting a reference angle. It should be between 0 and 90. Vy, 137.9, 157.6. Should be roughly in the 50-degree range, I think. Or in the 40-degree range, 41.2 degrees. So the final velocity vector in polar notation is 209.4 meters per second. That is the reference angle. To get the absolute for a fourth is 360 minus your reference angle. So 360 minus 41.2 or 318.8. Now obviously one could ask the question, would this whole thing be a problem on a test? Answer, no. I keep asking for 8-hour tests from Chancellor Vitter. He keeps saying no. You call them tests, I call them celebrations. Who wouldn't want to do physics for 8 hours? So for this, that's the velocity vector. I could see this being a problem or that being a problem, but not the two together. The last part is give me the height, the maximum height. Now let's talk about what's going on. In the first two problems, that was our starting point and that was our end point. Now this is another valid type of problem. What I'm looking for is that point right there. And I'm looking for that height. So now we're going to do a little bit of an observation. What do I know about the velocity of a two-dimensional motion problem when the object is at the top of the curve? It's pure horizontal. In fact, it is the vertical velocity is 0. And so one of the things that I do ask in one-dimensional motion I don't care if I break this. When you throw this up, when it hit the top of the curve, what was its velocity? 0. Trick question. If I throw this object up in the air, at the top of the curve, what's acceleration?
-10.
Excellent. I'm so proud of you. If you throw this object up and you think that the acceleration at the top of the curve is 0, that tends to be the most common of answers. What's wrong with that idea? If I throw an object up in the air at the top of the curve, why wouldn't the acceleration of the object be 0?
There's always gravity.
It's under the influence of gravity. One of the things that I tell the students, someone who says, oh, the acceleration at the top of the curve is 0, I say, well, what you're telling me is, I throw this up, the whole planet is sitting there going, wait for it, wait for it, wait for it. Turn off gravity, turn it back on, and now it's coming down. It doesn't make sense. Gravity is a constant. And I also say this, your parents think you're special. Earth doesn't care about you.
Oh.
So, to throw an object up, it's under the influence of gravity from the beginning to the end. Remember what I said, acceleration will either be 0 and a constant. So if it's 0, it's always 0, or non-zero. So if it's -10 at the bottom, it's -10 at the top, it's -10 in the middle. I did ask a question in the test. If I drop an object from 100 meters, what is the acceleration of the object 20 meters above the ground? If I drop an object from 100 meters up, when that object is 20 meters off the ground, what is its acceleration? It's still -10. What was funny is that the person who sits in that chair was reading the test and she's flipping through it and then she just looks up and goes, seriously? And I was like, yeah, I'm playing it. But it's to let people know that acceleration is a constant throughout the problem, from beginning to end, regardless of where you are. So, the way, when you hear about maximum height in a two-dimensional motion problem, or maximum height in a 1D motion problem, what you do is Vx is equal to V naught x, and Vy is equal to V naught y plus AT. At max height, you know for a fact that Vy is 0. You know for a fact. We're at this point. V is in that direction. So in this case, V naught y is equal to negative AT, or V naught sine theta is equal to negative AT, or V naught sine theta over negative A is equal to T. That will give us the time it takes to reach max height. So let's plug in values. 200 sine of dumb 38 degrees minus of minus 10, and that will give us 20 sine 38, 12.3 seconds. That's the time marker at the top of the curve. Now, one of the things that you can tell that you're on the right path is the max height time must be less than the total time, 26.1. This is 12.3. Question: why isn't this time, why isn't it half of 26.1? Because you throw an object up in the air, time up is equal to time down. Why is it not equal?
Because you're throwing it off.
You're throwing it off the cliff. The surface is uneven. You cannot assume, you just can't take 26.1, cut it in half, and that would be the maximum height. If the surface was even, I allow that shortcut. But if the surface is uneven, you have to do it this way. You can't do it any other way. So 12.3 is the time. We need to find max height. Y equals y naught plus v naught sine theta t plus 1/2 at squared. Now, if we plug in a time of 26.1, we will get a y value of 0 because that is the point at the end of the motion. But we're going to plug in 12.3. Y naught, 200. Yep. V naught, 200. Sine, dumb 38. T, 12.3. Plus 1/2, negative 10, 12.3 squared. And that gives us $958 meters. Could write 958.1, it doesn't really matter. But 958. If you wrote 960, I'd be kind of like, I don't know. If you wrote 1,000, I'm like, wait a minute, you're really rounding freakishly. 2, 3 sig figs, that's all I really need. And so that's the problem. When you're dealing with position and time, you roll out those x and y position equations. When you see max height, you roll out that vy velocity equation and set it equal to 0 and then work from there. So what I'm showing you are all the different variants of problems that could crop up. So that answers problem 13. You're welcome. Next question. We got about 12 minutes. Anybody got a question? Otherwise, I'll make up one. The vector addition on number 7? That's a grind problem. But I got 12 minutes. I could probably do it. We'll at least break it down. I'll work until 11:50 and then I'll stop. I'll get it as far as I can. Number 6, problem set 2. Is that, wait, 7? Oh, that's, okay. Because I did 6 on the tutorial. Oh, I know where you're getting at. Because in a lot of times on the tutorial, I go, which problem do you want me to do? And they go, problem 1. And then I do problem 1, and then they go, all right, now do problem 2. And I'm like, I detect a pattern here. But the thing is, homework's only 10%. I have no problem doing the homework for you because it gives you a chance to see it being done. And I believe in knowing how to do it on the test is more important than trying to go blindly into the homework. I write 7.4 at 232. 232, third quadrant vector. So I write a third quadrant vector triangle. That's my reference angle. The reference angle is absolute minus 180. So that becomes 52 degrees. I have a reference angle of 52 degrees. This is a x, which is a cosine theta r. This is a y, which is equal to a sine of theta r. This becomes 7.4 cosine 52. This becomes 7.4 sine of 52. .4 sine 52 is 5.83. I tend to write an extra digit for this just because it's an intermediate value. 7.4 cosine 52. If I truly was going to add vectors, I would do it on a spreadsheet and get an exact answer. 4.556. It's a third quadrant, so a vector is equal to minus 4.556 x hat minus 5.831 y hat. So that's the first part. That's the a vector breakdown. The second vector for number 7 is 143 degrees, so 6.3 at 143 degrees. That's a second quadrant vector. by, which is b sine theta r. This is bx, or b cosine theta r. It's 143 degrees. The reference angle is 180 minus theta a. So this becomes 180 minus 143 is 37 degrees. So this becomes 6.3 sine 37, 6.3 cosine 37. .791 5.031. So B is a second quadrant, which means the x is negative and the y is positive. So B equals negative 5.031 x hat plus 3.791 y hat. And so those are the sums, or those are the vectors broken down from polar to component. Now to add these up, I get negative 2.04 y hat minus 4.556 minus 5.031 minus 9.587 x hat. And to let you know about the test, this is not like a test problem in the sense that I would make one of the vectors an instant conversion and I would make the other vector typically a multiple of 10. Not this weird, strange 232. Most likely a multiple of 30 or 45. So this is my C vector. You can flop the signs and get the equilibrium on your own. But I'm going after, I want to know the final angle in polar for the resultant. Negative, negative, third quadrant angle. Reference between 0 and 90, absolute between 180 and 270. Draw my C vector. CX, CY. CX is 9.587, CY is 2.04. C is Pythagorean theorem, cx squared plus cy squared. That gives me 9.587 squared plus 2.04 squared. .8 meters. The reference angle, which is always the inverse tangent of the absolute value of the y divided by absolute value of the x, 2.04, 9.587. That gives me a reference angle of 12 degrees. Now I'm rounding. Answer is 12.01. I don't care. Make it 12. That's close enough. My graders are petty, but they're not that petty. The absolute angle for a third quadrant is 180 plus the reference angle. So the answer is 9.8 meters at 180 plus 12, or 192 degrees. And that's done. So it's problems 1 through 5 of the vector addition. There's all this quirky little stuff, but 6 and 7 are just power grinds. Yes?
For the equilibrium one for separate A.
Yeah. You just subtract 180 from 192. Yes?
Why does the angle have to be more than 180?
Why does the angle have to be more than 180? It's because when I wrote it, the component notation, it's negative, negative. That's a third quadrant vector. So the absolute angle has to be greater than 180. All right. Any other questions? Going once, going twice. All right. Have fun and go home.